So, thank you very much for coming. Welcome here. You already heard a few talks, and this one is kind of closes program for before the main talk in the evening. And I'm really glad that you are here. And I'm very glad to present the next two speakers, both from TNG, Konstantin Pervunin and Dr. Stefan Steinfurt. Yep, that's the way it is. Konstantin holds a computer science degree from the Technical University of Munich and specializes in machine learning. Previously, he had worked on embedding-based semantic search systems in the field of natural language processing, before dedicating his full attention to the chess AI. Stefan earned degrees in physics and mathematics at Heidelberg University and the University of Cambridge, after which he completed PhD in theoretical physics, focusing on string theory and black holes. After his early career in autonomous driving, he currently works as a team lead in the area of smart home solutions at an international home appliance manufacturer. For over 20 years now, Stefan plays online chess and is currently holding a blitz rating of 2400 on Lichess, which puts him above 98% of all online players. The project they're about to present is a combination of their passion for chess and professional expertise in machine learning and artificial intelligence. Please welcome Konstantin Pervunin and Stefan Steinfurt.
Yeah, hello everyone, thanks for coming. Nice to see so many chess enthusiastic people here, or AI enthusiastic people. Let's start off with a small question. So who of you has been playing chess online or offline recently? Okay, wow, quite a lot of people actually. I hope you had one more square than that poor guy who only has a 7x9 chessboard. So yeah, obviously you know that hallucinations are still quite a big thing. And yeah, who likes to watch chess YouTube videos? Anyone? We have published a couple of those, so yeah. So actually, there's quite a big community of chess lovers online. Millions of people are watching chess YouTube videos and yeah, playing. There are a lot of very interesting streamers. There is Hikaru Nakamura, who is one of the best players in the world, here in the very middle. He even cooperated with Mr. Beast at some point and yeah, beat him with only a queen and a king. There's also Levi Rosman, International Master Levi Rosman, also known as Gotham Chess. He portrays himself as the chess coach of the internet. And yeah, his videos are very educational. I can highly recommend them. There's also Anna Kremling, who is coming from a chess family. Both her parents are chess grandmasters. Her father has been Spanish champion a lot of times. Her mother has been Swedish champion and one of the best female chess players ever to play the game. And what she presents here is the Nescafé Frappé attack in the what is it again? In the Volga Gambit, I think. No? Different one.
I also don't remember, but
yeah. But apart from these chess streamers, which are all loved and where you can already see some of them are the best players in the world, some of them are not, but still are very good chess players, all of their videos are very educational. But in this week, there's also been some really, really tragic news because one of the other very famous chess streamers, Daniel Naroditsky, died only at the age of 29. And that's really, really, really sad. And I've watched so many of his videos and they are also extremely highly educational. And yeah, already a couple of months ago, I remember talking to our partner, Christoph Stock, who recommended the speedrun games in which he plays against lower-rated players and so on. And it's really, really tragic that he died a couple of days ago. There are a lot of chess platforms, as Dennis has already said. I've been playing chess online for more than 20 years, so I've basically seen them all. These days, there's mostly chess.com and Lichess. They have a very different model how they're dealing with people. So one is a really like for-profit company where hundreds of million people are registered and where there are different subscription models and so on and so forth. And Lichess is a non-profit organization. The whole source code of Lichess is open source, and you can contribute to it. And it's all donation-based. TNG has already, in the last years, hosted several people from chess.com and Lichess. Here you can see Sebastian Kunert, who was here at the last big tech day. He was one of the main managers to organize the joint venture between chess.com and the Play Magnus Group. And here on the right-hand side, you see Thibaut Duplessis, who is the founder of Lichess. So a lot of people are playing chess online, and they are many of them are analyzing their games after they played. But sometimes it's difficult to understand what a chess engine might tell you. So here there's a very complicated chess position. As you can see, white has 2 queens, but not so many other pieces. But black has, it's a very cramped situation and has only 1 queen, which is obviously like the normal case, right? And what does a chess engine communicate to you? It tells you the objective evaluation of the position is minus 0.5. What does it mean? Well, it means it's basically equal. But you can see from this very unequal situation where there are 2 queens on one side and 1 on the other side, it's really difficult to understand what's really going on in the chess position. But chess engines really more or less know the objective truth these days, I'd say, about chess positions. So for humans, they are much, 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 much better than even the best players who ever played the game. At the same time, there's the whole development of large language models, where you can also try to play chess against. In that particular situation, we asked ChatGPT what it would recommend as a best move. And it recommends to sacrifice the queen and take the bishop on c4. Sorry, so I wanted to highlight the c4. That's different. Okay, but what can language models do very well? Obviously, they can create text very well. So our idea, or rather the idea of TNG's partner Christoph Stock, who is also the unofficial chief chess officer of TNG, was to combine the strength of both approaches and create YouTube videos from it. There are many other parts of the whole idea, what we try to do here in this whole project, but the main focus of it is get the objective truth of a traditional chess engine and pass it on to a large language model to explain what's actually going on here in the situation. And so we tried several attempts. And Konstantin will try what was started first.
Yep. Thank you. It was actually the problem I had to solve. We are given some chess game, or you can take your own chess game. Then we want to perform some analysis of the game and create video review of your game. So the question is, of course, how to represent the game and how to make some computations with it. For this, normally one uses PGN, Portable Game Notation Format, which is widely supported by such websites like chess.com or Lichess. It is more or less the same as if you write your game on a paper when you are playing tournament. So it has main line of the game, but it also can have variations. Variations, these are such move sequences which could have been played but were not. And if you are playing chess game, you normally compute many side variations to know what your opponent can do against you and also to have more options to choose for your moves. Also, you can store comments on every move in PGN format and move annotations like blunder or brilliant move, which makes your analysis richer. So yeah, we take the PGN notation of the game, and after that, we want to perform an analysis. Sometimes I also play chess, even though I cannot call the opening from the unexplored video. So I thought, OK, I define some components which will perform parts of the analysis, and then I apply them to the game. So implemented were, for example, opening explorer, puzzle detector, plan finder, and many other tools. After that, they will be applied on the PGN file. Each of them understands something about the game, extracts important features, analyzes them, and extends the PGN file with variations, annotations, comments, and so on. And this annotated PGN file will be then commented by GPT-4. So GPT-4 creates human-like comments. And after we get analyzed and commented PGN file, we can convert it into a video. So the process looks like this. We take PGN notation of the file, consequentially apply all the components, and after that, create a video. Doing this, we create some game reviews from the World Championship match last year, where played Team Liren against Cook HD. So you can find this video reviews on our YouTube channel. The problem with the whole game reviews is that they can take too much time. For example, if the game is complex with many mistakes, with many opportunities for both players, the video can take up to 40 minutes. And of course, if you want to improve your components, you have to review this video maybe not once. So the feedback cycle will be quite large. You create one video, it takes also some time, then you review it maybe twice. And only after that, you can think what parts of the analysis system can be improved. So we switched to puzzle videos. What is a chess puzzle? Chess puzzle is a special position in chess where one move is much better than all other moves. And normally, it involves some tactic motives, so it's not the obvious move. The difference is that the solution of the puzzle is normally 4, 5, maybe 6 moves. It's much shorter than the full game. And we can generate the solution using Chess Engine, because Chess Engine knows everything about chess game. Also, good thing is that for analyzing this short game, we can use more or less the same components as for the full game. So after that, we can generate shorter videos using more or less the same components, review these shorter videos, and improve components based on this feedback. Also, it's quite easy to understand if puzzle solution is good or not. So we have to check if the solution is correct, if the system explains why at the end you are winning after performing all correct moves, and why your ideas doesn't work, and also why the opponent cannot defend against the solution. So here you can see one of our first puzzle videos.
We're diving into a thrilling chess conundrum today, pulled from a 2021 matchup between Nakamura and Svidler, in which Svidler, playing black, found We're diving into a thrilling chess conundrum today, pulled from a 2021 matchup between Nakamura and Svidler, in which Svidler, playing black, found an explosive tactical opportunity. Now it's your turn to step into Svidler's shoes. Ready? 3, 2, 1, go! Knight to h3 check, a strong move. G takes h3. Bishop d4 check. King f1. Rook d1, delivering checkmate, a good move. Black triumphantly ends the game, cornering the white king with a decisive checkmate.
You can see that this video is not that engaging. We simply show the correct moves and say that, yeah, checkmate in 1 is a good move. Well, of course, we wanted to improve it. And here you can see improved version of chess puzzle video.
Let's delve into a fascinating chess puzzle coming straight from the historic Alekhine-Wexler match. Put on your thinking caps and see if you could solve it for white. White's slightly behind in material with 2 extra pawns against black's knight. Both sides have their pieces actively placed, but black seems to have slightly better coordination and a well-protected king. The accurate resolution for this situation would be white's rook swoops in, capturing black's bishop on e7 and giving a check, forcing black's king to retake on e7, only to be checked again as white's bishop smartly repositions to a3. Should black opt for moving the king to e8, it doesn't necessarily improve the situation. It simply doesn't fix the problem at hand. The subsequent variation could bear a resemblance to our main analysis. In an attempt to evade the check, black's king maneuvers to d7, a move that subtly shifts the dynamics of the game. Let's take a look at how this might unfold. White's queen boldly takes black's queen on f7, giving a check, forcing black's king to flee to c6, only for white's queen to deliver a swift checkmate by moving to b7. A stellar finish. Now, let's swing back to the main line. Black's king hastily retreats to e6, escaping the check, only to face another check as white's rook slides to e1, pushing black's king to d7. Then white's queen sweeps in, capturing black's queen on f7 with a check, causing black's king to withdraw to c8, but it's game over as white's queen lands on b7, delivering checkmate.
Maybe also not perfect. For example, moving king to d7 and losing queen and in one move does not really, how it's said, shift the game. Maybe not. But here you can see smooth animation of moves, and also the comments on moves are not just calling the moves, but explaining what they do. And it was side variation, which was color-coded. So yeah, some improvements was done on puzzle videos. And we also published such puzzle videos on YouTube channel. The newest idea was to create checkmating shorts. How we create them? We search in online tournaments, mainly online, like Lichess, Titled Arena, and we detect games which end in some interesting checkmates. For example, the king was checkmated in the center of the board, or 5 or more pieces they took part at checkmating the opponent's king. We extract such checkmating sequences from these games and create shorts about the checkmating patterns. This is the third type of content on our channel. Here you can see how it looks like. We published more than 260 videos and accumulated over 180,000 likes, some subscribers, and more than 1,000 likes. Most of these achievements we got in the last 3 months. But this all was the previous generation video creation. So now we started to create videos using agentic-based system, and Stefan will talk about this approach.
Yeah. Thank you, Konstantin. So 2025 has been called the year of agents. Andrej Karpathy even said the next 10 years will be the decade of agents. And what are agents good for? Fundamentally, they are good for open-ended problems. And actually, analyzing a chess game is something you can spend many, many hours on it. So it very much resembles an open-ended problem. And basically, we took a couple of things from the older approach and switched out the main components. So we still have the video generation and definitely profited a lot from it and could reuse it. But the chess analysis is now done completely differently. Before explaining all the details of how this exactly works, here's a 5-minute video of a famous chess game played between two of the strongest grandmasters in the world. On the left-hand side, playing the black pieces, there was Mikhail Tal, who used to be world chess champion. And there's Jonathan Spielmann, one of the best British grandmasters of the 80s. And let's watch it.
Hey, chess fans! Today we're diving into a brilliant puzzle from the 1985 Taxco Interzonal, where British grandmaster Jonathan Spielmann faced off against the legendary Mikhail Tal, the magician from Riga and former world champion, famous for his daring attacks. Tal, playing black, turns a tricky position into a king hunt. White's king is exposed on g3, with a knight lurking on g4 and open lines everywhere. Black to move and win. Let's break it down step by step to see the tactics and concepts that make this shine. First, spot the candidates, checks and threats. The winner is sacrificing the rook to open everything up. Black sends the rook from e8 straight to e3, checking the king on the third rank. This deflection pulls White's f2 pawn away, wrecking the pawn shield and exposing the king even more. Key concept. Sacrifices like this create tactical chances by forcing your opponent to react. If White ignores the rook and runs the king to f4, that's a quick loss. Black's queen could slide in for a deadly check, leading to mate soon after. Or trying to block with the pawn pushing to f3? Still bad. Black's pieces overwhelm. For something interesting, suppose White blocks with the bishop sliding to f3. It stops the check on the rank, but now Black's queen jumps in. Queen from d8 to d6, checking on the long diagonal. Attacking through empty squares to g3. White's king must go to h3. Then Black delivers mate, like with the queen to h2. Queen to h2 protected and attacking h3, no escape. Highlighting h2 shows how this weak square lets the queen sneak in for the kill. Concept, watch for back rank weaknesses around your king. Or even the knight from g4 capturing on f2 for mate. Another way to end it, knights love jumping into outposts near the enemy king. See? Blocking looks safe but fails fast. Teaches why you need to calculate opponent responses. Back to the main line. White's best is capturing the rook with the pawn to e3. Rook gone, but Black follows up strong. Queen to d6, checking on that diagonal again. Slicing through to g3. White's king dodges to f3. h3 would allow a quick queen to h2 mate, as we saw. King to f3, escaping but still vulnerable. f3 seems okay, but it's no safe outpost. Black's knights control nearby squares. Now Black's knight from c6 jumps to e5 with check. Knight to e5, attacking the king. Perfect coordination. Hitting f3 and that L-shaped knight's adore. White's king runs to f4. King to f4, but Black keeps chasing. f4 looks open, but it's weak, exposed to more attacks. Black's knight, now on e5, leaps to g6 with check. Knight to g6, forking and checking. Attacking f4 relentlessly. White's king back to f3. King to f3 again, trapped in the dance. f3 highlighted once more. No real safety here without piece support. Finally, Black's knight captures the bishop on h4 for checkmate. Knight takes on h4. Mate. The king can't flee or capture, with all squares covered by Black's knights and pawns. Concept. Knights excel in king hunts because they jump over blocks. h4 was a loose piece. Always protect or move them in tense spots. What a sequence. Tal's sack leads to a 5-move mate, showing how tactics like deflections and knight coordination win games. Weaker players, remember, prioritize king's safety and calculate forcing moves. Tal pulled this off in a key tournament, proving his attacking genius. Drop a like if you learned something. See you next puzzle.
Maybe consider subscribing as well. So yeah, as you've seen, the chess analysis of the whole puzzle situation is much more diverse. There are biographical details scattered into the whole storytelling of the agent. There are more animations like arrows and square highlighting. Actually, the LLM decides what to highlight. The variations which we see are shown in different styles, so sometimes they are just mentioned and not really shown on the board. Sometimes they are visualized with arrows, and sometimes it's really shown on the board what happens. Why? So I already mentioned that we basically changed the whole approach because it's more fitting to this open-ended nature of analyzing chess games. We already tried that last year, actually, but last year didn't work so well. But there were a couple of things which changed in the meantime, and in the end, what this agentic approach to analyzing chess games gives us is a much more scalable approach. So we are all expecting there to be better LLMs coming out every few months, right? And that is something which we'll definitely be profiting from in this whole approach. There are much more simple integrations, so the biographical details come obviously from a quick Wikipedia search, as you can imagine. It's also possible to integrate chess book knowledge. There are many chess books out there and other kinds of contents which we might be able to integrate more easily. In general, the whole implementation of this agentic approach is also much more maintainable because it's, in the end, much less code. And a lot is less hard-coded. So basically, the agent decides what to look at, its variations, and then calls the chess engines from time to time. And we don't decide beforehand how to best deal with these situations. So we'll come back to some of these points a little bit later, but first I told you something changed. What was it what changed? Oh, maybe I'll skip that actually. So what changed is we're using now a different large language model. In the summer, I think it was in August, there was a chess tournament organized by Kaggle and Google DeepMind, where they had all the big LLMs play chess against one another. There was Claude Opus 4, DeepSeek R1, Gemini, OpenAI's O3, and there was also Grok 4. There was a lot of live commentary by the chess streamers you saw earlier. Hikaru Nakamura had a live stream explaining all the chess which was going on. Levi Rosman had a daily recap, and also the former world chess champion Magnus Carlsen chimed in for the final. On the very first day, something really spectacular happened. Grok 4 was actually playing really good chess. It was playing so good chess that Hikaru Nakamura said, well, it's playing incredible chess. He also mentioned it's sort of sometimes even like close to playing like a grandmaster. I was really surprised by that. Levi Rosman said in a different style, he said, Grok is a monster, dude. But also Elon Musk tweeted on it, obviously. But he mentioned it's just a side effect. There's no like special handling going on in any case. They didn't do any special training on chess or anything like this. So it was really mysterious why Grok was playing so much better than the other ones. But that's only the first day. On the second day and in the final, Grok also played a lot of like really bad moves, like in this particular position where it was playing bishop to b5. And if you don't know chess too well, that piece can be taken, and it's really like an objectively really bad move. And the grandmasters commentating, David Howell and Magnus Carlsen, they were really laughing at it and really were wondering, so what's going on? Did they like switch off an engine or something like this? Obviously, an engine was prohibited, but for us, it's not prohibited, right? And yeah, in the end, Grok lost the final against OpenAI's O3 because it made a lot of mistakes. But still, there was quite a lot of interesting things about Grok, which we observed when looking at the games. So first of all, I mean, what would we want to have for a good language model to describe chess positions? Obviously, it should be a very good reasoning model. And when it was published in July, Grok was really scoring extremely high on the most important reasoning benchmarks. So on GPQA Diamond, it got the top position. On Humanity's last exam, I think it solved 50% of these extremely difficult problems. No human would be able to do that, I'm sure. And there's also an interesting intelligence benchmark called ArcAGI, in which it was really like a complete step beyond all the other existing language models. What was interesting about Humanity's last exam was there were different kinds of how the questions were solved. And when it had tool calling allowed, it was getting this 50% result. So it's really good about tool calling, and that's definitely some quality which we also would want to have in our situation, because we want the reasoning engine to understand when to call a chess engine and when not. When looking at the reasoning, or like part of the messages which were shown in the live streams for the chess games, it was also interesting to see that somehow Grok understood the geometry better of the chessboard better. we have seen in the video that it really said when the queen was checking the king that it was happening on the diagonal, and that's because in between there were no other pieces. And in the meantime, so for quite a while, our whole approach only worked with Grok 4, but these days there's also Claude Sonnet 4.5, and for that one it also works pretty well. What you might be wondering is, why didn't we pick the winner? Come on, O3 won the tournament, so right, that's the one to pick. Obviously, we tried it out, but it didn't work as well as with Grok. And to some degree, it's still a bit of a mystery why it didn't work that well. But yeah, our impression is it's maybe about like the good combination of tool calling with the reasoning, that it's just a little bit better for Grok, and because in the tournament no tool calling was allowed, that maybe just like the bare bones large language model as O3 was better than Grok without any tool calling. So what else do you have to think about if you want to design an agent? It's first like the language model you're using, or yeah, you might be using different language models in different parts, but obviously like what is the core thing to think about chess positions? That we now saw, it's Grok 4. So Grok 4 basically coordinates the whole analysis of the chess game. That's what happens here in this analysis node on top. It's a relatively simple agentic design, so mostly what's happening is that Grok observes the chess position, thinks about it, calls a tool like a chess evaluation tool, like a chess engine, would then get back the result and somehow think about what the outcome was, which one is the best move, and so on and so forth. The memory of the whole agent is pretty simple. It's just like a short-term working memory. So basically, when implementing it with LangGraph, it's just the list of messages exchanged between the language model and the tool output. It's relatively simple that it just sometimes decides to call this tool and that tool. So there's no like other more complicated planning involved here. It's just like internal planning of the language model itself. And after the analysis has been finished, it would pass on the analysis to a writer node, which would then write out the whole analysis of the chess position into a specific format. And before creating a video from it, we would check for some consistency. So there's sort of a feedback loop here on the very bottom as well, which Konstantin will show in more detail later on. So in the end, what we've got here is something which you can basically just get out of the box, out of most of the existing agent libraries. It's a so-called React agent, which stands for reasoning and acting. So it's just calling tools and then getting the output and then reasoning on the output. Interesting, if you want to have some reading recommendations, I'd highly recommend looking at the papers which this main author here, Shunyu Yao, published. There's the React, the reflection papers, Tree of Thoughts, a lot of very interesting benchmarks like SWE-bench and so on and so forth, which might have already been mentioned here a couple of times today. And yeah, I highly recommend looking through these papers which he participated in. So I've already told you that the agent would be calling a lot of tools, but the question is which tools, obviously. So we've basically categorized them into three kinds. So there are chess evaluation tools, like calling the chess engine. Also, sometimes language models are relatively bad about really seeing which moves are the ones which set the opponent into check, or what capture moves are, and so on. We also have other tools which interact with the environment. The environment here in this case is a virtual chessboard, which we give the agent, on which it will be able to play moves and rewind them, and by this work through the whole situation. Because language models sometimes get a little bit confused, we also provided a pieces tool, which the language model can call to get feedback on where actually all the chess pieces are still positioned, because it might easily forget that. I already mentioned we do some Wikipedia search, so there's obviously also a web search tool, and there's also a special think tool, which I'll explain in a minute. But maybe let's first focus on the chess tools. So if you teach chess to beginners, there's some method which is really helpful. It's about some structured thinking, about thinking of what checks, captures, and threats are. So in the puzzle position which we saw earlier, there are just 4 check moves. We already saw the rook sliding up to e3 in the very middle of the board. We also saw that somehow in this whole solution of the puzzle, playing the queen to this long diagonal onto d6 or c7 was somehow important. And you can also see this arrow going to the side, capturing the bishop. That's actually not a good move in this position, but it's one of the check moves. And the method basically tells you to consider these moves because sometimes one of them might actually be key to the position. There's also captures in this position. The knight in the very middle can be taken by our knight on, c6. I already told you that the queen can take the bishop on the side of the board, and there are a couple more check moves, capture moves. So in this particular position, the capture moves were actually not that important, but in other puzzles they are. And that's something which we basically told the language model. Look for checks, captures, and threats. So what came out of it? We combined this all into one tool call, just to have it not to do many tool calls after one another. And here you can see what came back from the tool. There's basically a list of checks, the list of captures. There are also some threats, like moving the pawn up to g5. Or, if it were white's move to play, white would capture the queen with the bishop. So these are all things one could potentially consider when analyzing the position. There's also this think tool. It's a little bit magic, and it doesn't do much. It just thinks about a position. So you can see the tool description here. Use the tool to think about something. It will not obtain new information or change the database. Okay, we don't have a database here, but that's literally what we copy-pasted from Anthropic. But it will just append the thought to the log. Use it when complex reasoning or some cache memory is needed. We do have complex reasoning here in chess positions. And for those situations, Anthropic very much recommended this kind of tool to basically look at the situation of the chess position, write out some observation and append it to the messages array. And that was very helpful for Claude's own benchmarks, for Anthropic's benchmarks on Claude Sonnet, for the software engineering benchmark, or for Tau Bench. And for our situation, it's also very, very helpful because we exactly are in this situation where it's about complex reasoning with many, many consecutive tool calls. We have a very detailed system prompt, as you can imagine. First one is obviously our chess agent is supposed to be a chess grandmaster and providing educational content for chess players via YouTube videos. We have also put in some chain of thought part where we nudge the language model to really use the provided tools to look for intuitive moves, but then also for checks, captures, and threats. After looking for these moves, it should be evaluating them. What would it evaluate them with? With the evaluation tool. And at the very end, we also tell it to some key principles, so never even to consider illegal moves or something like that. And there's also some part about doing Wikipedia search about the players. What I already mentioned earlier is we need some kind of structured output at the very end to get a video out of it. And that one, Konstantin will tell you about.
Yep. After the analysis node performs the analysis of the position which we provide, or maybe even of the game, it goes to the writer node And writer node observes the whole history of the tool callings, some thinking process of the analysis tool, so it knows everything about this position. The task for the writer node is to write the review of the position with text, where text defines which moves we want to present over the board, which arrows we want to show, which squares we want to highlight. And this output should have a standard XML format, which is known to LLMs. And text checker will check it. If it's not correct, then we go back to writer and remake this output. Otherwise, we are ready to create a video. How can we create video? So we have, for example, something like this, XML file with some text for moves, for arrows, and for square highlighting, and the comments we want to have in our video. So the first step is to go into the PGN format, because we worked with PGN format before, and we have already the system which converts PGN files into videos. So we simply replace all move text by the real moves. And we save all the comments and all other text as comments to the moves, because PGN supports it. Also, good advantage of PGN format is that PGN file guarantees that all moves are correct, which means if you, for example, want to edit this file afterwards, you have to write correct moves. So after we observe PGN, we can see something like this. And then we simply generate video. We show moves, and in parallel, we generate audio comments from the text using text-to-speech models. The only thing we have to do is to remove the arrow and square tags and store the positions where the tags were in text. And after we create audio, we know at which moment we arrive the position of the tag, and exactly to this moment we show what they define on the board. So here you can see short video part, which corresponds to exactly this part of the PGN file.
Knight 2 g6, forking and checking, attacking f4 relentlessly. White's king back to f3. King to f3 again, trapped in the dance. f3 highlighted once more. No real safety here without piece support. Finally, Black's knight captures the bishop on h4 for checkmate. Knight takes on h4. Mate. The king can't flee or capture, with all squares covered by Black's knights and pawns. Concept. Knights excel in king hunts because they jump over blocks. h4 was a loose piece. Always protect or move them in tense spots.
So yeah, for example, you have seen that the arrow defined here, arrow from g6 to f4, here was shown exactly to the moment when attacking f4 relentlessly was set. So this is how we modified a bit video creation system to support the agent-based video creation. And this type of video is probably our state-of-the-art videos. And about the next steps in the project, Stefan will tell you.
Yeah, so you might be wondering, why are we even doing this, all right? One of the obvious answers is it's a research project, right? Chess has been an interesting area for doing AI research for decades. There has been Deep Blue in the 90s. There has been, what is it called again? AlphaZero, thanks. Like 10 years ago. And now how to combine language models with traditional chess engines for doing chess education, for example, is not a really clear solved problem. There's obviously training involved here. So we've learned a lot now about agents, or how to integrate different kinds of AI systems with one another, with text-to-speech, or we also have an avatar in some of the videos. And yeah, another part of it is we are doing some outreach here. We are having a YouTube channel. Many people have now already seen our videos there and might be excited about them. What we've not so much covered is like monetization. So currently, we are not yet there that we would be getting any money via the YouTube channel or something like that. But that might be changing at some point, right? And obviously, it's also sort of a passion hobby project for many of us. And yeah, I mean, just by the number of people here in this room, I know there are a lot of people who are interested in doing chess. So what are other things which we want to improve in this whole system? So I mentioned that we changed our approach to this agentic approach only very recently. So in summer, we switched it and implemented the agent. So it's very difficult in general, to be sure that our agentic system improves step by step. We've already put a lot of effort into very precise tool descriptions and having examples in there, which would really help the language model to understand the output of a tool call. But for the overall quality of the whole video, we have not invested so much in there. But that's an obvious step which we'll take next. Another idea is to do a more complex agentic architecture. So you might be thinking about some sub-agent to be spawned at some point to look only at a very specific variation, or to have a sort of a strategy agent and a tactics agent which might conflict in their evaluation of the situation. The whole memory management is very simple, as I mentioned earlier. So we might be wanting to write something to disk and then read it later on, or might store something from earlier analysis, which we might want to retrieve. So there's also a lot to do there. Another very clear next step is to do human in the loop. Currently, it's all automated. We press a button and then the whole video is being generated. But you might also want to interact with it. Maybe the agent has forgotten to look at a particular variation, or you might want to understand something which maybe is obvious to the agent but wasn't explained. And that's quite of a simple thing to add to the system. In general, extending it with more chess knowledge is another interesting step. So there are a lot of interesting chess books, like the one in the very middle, or the integration of opening books like on DChess and so on might be another interesting avenue to take. From the application side, we have now shown you that the agent does analysis of a chess puzzle, but we might want to go back to the whole game analysis. And for doing so, things like the memory management might be very important, because it will have to look at a lot more moves, a lot more variations, and might go out of context there. What we've already experimented a little bit with is doing a different format of the presentation, so having a dialogue style. It already works pretty well, but it's not completely finished. Another very interesting approach long-term would be to do more live commentary. There it's more difficult, of course, to have the analysis and the commenting generation being done at the very same time. But for this 5-minute video, it was like 5 minutes of analysis, so it's actually not so unrealistic to do so. And another avenue is obviously to do a personal coach, right? So you might want to have give people the possibility to look at their last games and look for patterns, and teach the people what they might be doing better and what they should be doing better in their games. And that's about it. So the only thing left here is thanking a few more people who contributed to the project. So in the middle, you see Christoph Stock, who originally had the idea and collected all of us, and still has a lot of ideas what we could be doing next. There's Christoph Niehoff and Luc Schnell, who helped with a lot of the automation parts and speech generation, and might also be improved even more. You might might have heard that there was not that much variation in the different styles, but there's already something coming there. And with that, I'll close and just say, please like and subscribe. And also come. And we also have our showcases down there, where we show more things in detail. And if you want to reach out, send us an email.
Okay, thank you very much. And now we have some time for questions. Oh.
So it seems like so far the stuff you showed us is mostly focusing on like tactics, right, and explaining the tactics, which is something that I feel like even just looking at the Stockfish moves already is kind of very helpful. But what maybe Stockfish is less helpful is if you have like a position without tactics, right, and there's some strategic things that Stockfish really doesn't explain at all. Have you tried something like this, like giving it some positions like this and get some stuff?
Yes. So we a while back, like analyzing endgames was, for example, very difficult. But this approach also works a lot better in that area. And I think we profit a lot from the general chess playing capabilities of Grok there. And it would really describe better what's going on in endgames as well. So saying, okay, you have to move a rook on a particular open file and these kind of things. Also from our previous approach, we have built a couple of components which are more like tuned towards strategy. So we have a plan finder component, as Konstantin mentioned earlier, which is difficult concept in general, but where we're looking at multiple moves there and trying to find patterns in between the best variations, and then try to sum up what's actually happening, and then describing it as sort of a plan, which might be interesting.
Was also a small prototype of position description, which was like open-ended, where some schematic variations were defined, and then we extend the variation tree, applying more or less the same components as we presented before. And but it was hard-coded, so probably it will work better with agent.
Thank you very much. Very interesting for me. I have an on-off relationship with chess all the time, so I'm doing it, hitting a bar, coming back. And I'm happy about the question before, because the content that I'm now looking for is this kind of, let's call it, Capablanca style of playing, because that gets you structurally better. And there I like the content, and I think that's kind of in the direction. So, but in case you would like to train someone like playing the Capablanca way of thing, is that something that you could put into your backlog somewhere?
Yeah, so
I would be super interested.
Yeah, I mean it's very interesting in general, this direction, but also very difficult, as you can imagine. Yeah. So what we've been looking at in the past as well is some other components of what chess engines put out there. So for non-neural network-based chess engines, there are also components like where you have something like the safety of a king, or some evaluation of the pawn structure. And even though it doesn't really then tell you if it doesn't tell you the objective truth about if a particular pawn structure or something like this is really good, it still tells you that it used it a lot in its own evaluation, and then maybe combining it with something like a chess book, which tells you a little bit about particular pawn structures, that I think could imagine to work quite well. But it's definitely more complicated problem than looking at the tactics here.
We can continue onwards. I was thinking about whether you do kind of an optimization strategy where you moves that do not risk your position, and under those conditions you select good ones. That is a kind of interpretation of what it's done.
Yeah, I mean, there I could imagine that it's difficult to differentiate between the moves which are not relevant for the whole situation, or the ones which might improve your structure step by step and at some point will become important. Yeah. So yeah, it's a difficult problem.
Hi, thanks for the talk. I think I have a similar question to both of them, but coming from somebody that doesn't play much chess at all. So I was a bit, when you mentioned that you are using this AI to analyze puzzles, right? These puzzles, do they already have a solution somewhere? Is the AI aware of them always? Because I understood that it's evaluating a different paths to go, but it's its own choice which paths to evaluate. So could it be missing the actual objective solution to the puzzle?
Well, we basically provide the agent with the capability to look up the solution by giving it access to a chess engine. And that's usually sufficient for these tactics. And there will most of the time be one move, which is a lot better. But then still it has to try to find out why is it better. And this we don't tell it. But it still finds out about it by analyzing like adjacent moves and poking around a little bit here and there, and also using, for example, this intuitive moves tool, which I didn't explain in detail, but it will then tell you, okay, it's actually intuitive to play something like this, but that's the best move. It will take this sort of conflicting information and will reason on it to then provide an explanation why you might be thinking about the intuitive move, but the best move is actually a different one.
Okay, thanks. So the chess puzzle has always a solution. It doesn't just tell you this seems to be better. If it tells you this move is the best one, it's the best one.
Yeah.
Okay. Very nice.
And did you observe when you used it, if it would use the chess engine tool call multiple times? So would it use it once to determine the best move, or would it really try out and then?
We actually nudge it to do it multiple times.
Yeah.
So it might also lose track a little bit if it doesn't call it enough. So we basically told it to use it multiple times after like a whole variation and use it rather more often than too little, because otherwise it might easily happen that something completely different, which is like completely wrong, is then output. So we try to err more on the side of rather use it too often than too little.
And is the agent free to decide how much effort it wants to spend on analyzing one thing?
Yes.
And eventually it will say, okay, that's enough. And
yes.
Good.
Yes.
Okay.
I mean, we have a limit of, I think, something like 200 tool calls just to stop it at some point. But it's just like a general safety and money-saving measure, and not about like the analysis.
Thanks for the great talk. When you spoke earlier about the different tools that you've given this machine access to, one of them was the CCT tool, so captures and the other important ones that I forget now. But that sounds like some human bias might be sort of playing into the way you're teaching it to play chess. Because as you mentioned, this is how you teach people to play chess, always look for the checks, always look for the threats. Do you have an opinion on that? Like, do you feel like you've built in a lot of your own bias into this? Is there a way around it? Are you looking for a way around it? Is there a way to even test this?
If you're trained to explain it to human, then human bias is not the worst thing which had happened. But yes, of course, this system is also biased, and the system we had before is even more biased because there is, not a big amount of people who implemented it based on understanding of chess game of this people. So, yeah.
Did you experiment, or what are your ideas on plans regarding personalized coaches? So, for example, a beginner needs a completely different analysis than an intermediate player or an advanced player. Or I could also imagine that I might have taken a lesson, maybe from a book, and now I want to analyze my games regarding this lesson.
Yeah, it's a very relevant question. So most of us in the team are actually pretty good chess players, but some, I'd say not that much, but it's actually super helpful commentary to provide guidance and to say what helps someone who hasn't played chess online for 20 years. And for example, the arrows we have and the square highlighting are like super important for people who don't know how to play chess well, right? So these are visual components which we tried to build in, but from the educational part of it, yeah, I mean, it will sometimes be difficult to go below the level of like playing the correct moves or, yeah. Sometimes that system will probably rather describe the moves which are more like correct and not the ones which the human would be thinking about. But on the other hand, we plan to have it sort of more in a chat mode where you could be asking about particular moves and think about, okay, so I would think about playing g4 here, why is that a bad move? And then it would maybe giving feedback there. So yeah, it's not an easy problem to address, I'd say, but yeah, we try to learn also from people who don't play chess that well.
Okay, then one last question from me, because I control the microphone. So you're doing videos for YouTube, and some people should watch them. So how do you imagine your target audience? Because for some people, like taking the queen or like a mate in 2 is quite obvious and doesn't need to be shown. And for somebody else, maybe it is so.
Yeah, we don't target that much. We don't like actively do this. So we have a diversity of different videos. So some of them are really complicated puzzles, but some are relatively basic, like for someone who has been playing chess online for many years. And so we could be biased and say, okay, no, that's not an interesting puzzle, so we don't show the video. But we'd rather try to then say, okay, no, actually for like beginners, it might actually be very educational and interesting to also have the simple puzzle in there. Yeah.
Okay, thank you. No last questions. Otherwise, that's about it. And again, thank you very much for this beautiful talk.